So this is video 1.7, scientific notation. Our first here is to convert measurements to scientific notation and form scientific notation to standard numerical form.
And then we want you to recognize the importance of including units when you record a measurement. And to have a reading to go along with this, make sure you check out Chapter 2, Section 2.6 that begins on page 47 of your reading packet. So I'm fairly certain you wouldn't be this far in your school career if you hadn't already worked with scientific notation somewhat. Just to review, it's a convenient way to express very large and very small numbers. You can write any number in scientific notation, but when you have numbers that would have many, many zeros in them, if they were written in standard notation, the scientific notation becomes the preferred way to do it. So so we're all on the same page with the terminology, the number at the front is called the coefficient. And then the base is always 10, so the coefficient is always multiplied by 10 raised to some exponent, which could be anything from negative something to 0 to positive something. Yep. You can see this one has a positive exponent.
All right, so the process of changing what we call a standard number, or a number that we're used to looking at, to scientific notation follows these rules. First, you count the decimal places to move from the original decimal location to the coefficient form. And in the coefficient form, you only want one number, decimal, and then the rest of the numbers. You don't want point, number, number, number. You don't want number, 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 decimal, number, number. You want it to be some number, and then, so for example, like 1.3 times 10 to the 23rd, notice there's one number. You don't want this. You don't want this. You want it like that.
Only one non-zero digit to the left of the decimal.
And then, of course, write the coefficient and base 10. The exponent is the number of decimal moves. Exponent is positive if the number was greater than 1. It's negative if the number was less than 1.
So maybe we should work through an example or two here on this page. We'll clear it off and we'll show you some examples.
All right, so let's do an example real quick. Let's say we're starting with the number 100.
100.
So the original decimal point, of course, is at the end.
It's an understood decimal, but It's there.
That means we have to move it twice to the left, which means it's going to be 1 times 10 raised to the power of 2.
It's 2 because we moved it.
It's a positive.
2 places.
It's a big number. It wants that way.
We moved to the left. The number, like Mr. Hunter said, was big. It was larger than 1, so it's a positive exponent. So let's take another one.
Try 0.0015.
Okay.
So I now have to find the decimal, so I get the coefficient to the right place, which is 1 non-zero to the left. So that's 1.5 times 10, and since we move the decimal to the right, it has to be a negative number, so it's going to be negative 3.
Because we jumped it 3 places.
I think you're already comfortable with this, but that's a little bit of practice for you. You'll practice more later.
So now we're going to go through the exact reverse of what we just did, going from scientific notation back to a standard number. So remember, the exponent sign is going to tell you which direction to move the decimal. If it's a positive exponent, you're going to need to move the decimal to the right, so we want to end up with a standard number that's greater than 1. If it's a negative exponent, we're going to be moving the decimal to the left. This is going to be a number that's going to start out 0 point something. The exponent's value will tell you how many places to move the decimal to get from the coefficient back to the standard number form. So give me a number in scientific notation, Mr. Hunter.
I like 6.02 times 10 to the 23rd.
All right. If I knew how to work this, it would be even great.
Let's not do times 10 to the 23rd. Let's do 6.02 times 10 to the 5th.
Times 10 to the 5th. Thank you, because I really didn't want to write all of the
23 zeros, yeah.
Okay, so it's a positive exponent, so I know I need to move the decimal point this way 5 places. So I write 602. I go 1, 2, 3, 4, 5. There's my new decimal point. Fill in the zeros as placeholders. That would be 602,000.
Here's an important fact that will come up later when we do significant figures. That decimal is not actually there. Because if I put that decimal there, it would cause problems for our numbers. Just keep that in mind for now. If you want to write your
Right.
decimal, that's fine
Yeah.
for now.
It
but-
does, whether or not you put it becomes very, very important later depending on what the measurement was. He's absolutely right. Technically, the way that number was written, I should actually not be showing that decimal
no.
point. It's understood to be there, but you don't actually put it there. If you put it there, you're kind of telling
Let's
somebody
do-
something
yeah.
else about the measurement. Let's do
do
one with
another
the
one.
negative
Yeah.
exponent.
So let's do 3.18 times 10 to the negative 4.
Okay, so it's a negative exponent, so I know I'm going to need to move the decimal point this way. So again, I'm going to write 318, and I save some room at the left there. And I'm going to go 1, 2, 3, 4. Now here I do need to show the decimal
Yes.
because the number's less than 1, you have to show it. And then I just, again, fill in the zeros.
Of course, there's rules for when the decimal should or should not be written, but we're going to cover that
Yeah,
in the
we'll
lesson.
get
or two.
into that for sure.
Right. All right, so for this PVQ set, we have this nice table. Yes, we would like you to copy the table in. We want you to convert between the two different types of scientific notation. So for the first one, 6 times 10 to the 0, we would like you to write that in a standard or decimal notation. We'll do this first one with you just to be
Okay.
nice.
So we didn't really cover 0 as an
Well,
exponent.
well,
What
what's-
does that mean?
Yeah, if you take 10 raised to the power of 0, mathematically that equals 1.
So it's 6 times 1.
So it's 6 times 1, so it's 6. And then once you get the rest of these filled in, we want you to go through and rank them from largest to smallest. See
Okay,
if you
which
can
is,
do
I think,
that.
is a nice exercise too, so you kind of learn, all right, what am I looking at, which
Mm-hmm.
one's biggest or which one's smallest. Also note that all of these are measurements,
You have to include the unit.
so they have the unit of, in this case, they all have meters, so that's simple, but you notice how I put a meter on my answer, so to be, that meter stays there, whether we express it in scientific notation or standard notation.
So we'll cover this tomorrow in class, and have a good night.
We'll see ya.